our blood reveals a lot about our physical health. The shape of our blood cells sheds light on several hereditary diseases, for example. For a diagnosis, the cells must first be examined under the microscope and categorized into a specific cell class. We met Dr. Stephan Quint and Alexander Kihm of the Institute of Physics at the Saarland University, who explained how this classification works. Presently, the classification and characterization of cells from microscopic images still involves an experimenter who studies the individual cells and determines the shape or class of the cell. This classification is frequently prone to errors because the process is based on a subjective assessment. The research group led by Quint and Kihm has developed an analysis software that significantly improves this process. The analysis software is able to automatically classify and characterize cells. The software studies and objectively assesses the images. That means we created a mathematical algorithm that objectively evaluates the cells. The blood cell classification software is based on artificial intelligence. Quint and Kihm required hundreds of blood cell images, which they manually classified, thus allowing the system to ultimately learn the different types of cells. In our publication, we have made a distinction between two dynamic cell classes or shapes of cells, namely between a symmetric and an asymmetric cell class. To train the network, we had to collect datasets of these cell classes to feed the network. The benefits of classifying by using artificial intelligence are obvious because you eliminate human error and make the classification objective. Another advantage is the fact that, unlike humans, the network can process larger volumes of data within a specific time frame. The classification of cells into different classes is based on their shape. Thanks to the software, the scientists can instantly detect any changes. A changing shape essentially depends on the mechanical properties of the cells. If they change because of hereditary diseases or in response to medication, our software enables us to see it and draw conclusions about the cell population. The researchers' technology has laid the foundations for a rapid diagnostic test that could be used to diagnose malaria or diabetes in the future. And although this type of test is still a long way off from mass production, according to Quint and his team, artificial intelligence generally offers great potential for the medical sector. We expect that all procedures will be based on these principles in the future.